product and explain a bit more of what's the main topic of today. Maybe Anna, if you can just confirm, you can actually see my screen now.
Everything is okay.
Okay, perfect. So we'll start with a beautiful picture of our hometown. Based in Bergamo. Our company is based in Bergamo, which is a small town very close to Milan. So how LabTech was created and how did LabTech start dealing with the international market? So essentially, we are based in Italy. We have our headquarters here, where we have our QC and customer support department. So essentially, we deal from LabTech Italy with the international market. There is also other two headquarters of our company. One is based in China, and the other one is based in the US. So the other two headquarters are taking care mainly of their own markets, while LabTech Italy is taking care of the international market. So besides China and United States, essentially we cover the global market, manufacturing ourselves and providing laboratory equipment to different countries all over the world. What's our vision when dealing with our distributors like Alt and our customers? It's a global partnership, meaning that we are essentially covering global market and different areas of the world in terms of customer support and sales activity. Powered by knowledge, meaning that we have a team based here in Italy of 15 people taking care of both sales and customer support. Innovation and continuous improvement. This is one of our key points because we continue introducing innovating technologies such as Xelsius onto the global and defined by our people, meaning that we take care of both our team, first of all, and then, of course, our customers, because we believe them being a trustworthy company will always generate comebacks to our activity, our sales activity, plus from our customers. Just to give you an idea of what we manufacture and distribute all over the world, this is our complete product portfolio. So as you can see, top left is our Xelsius, so our reaction unit for organic synthesis. We have liquid nitrogen generators, gas GC application, and many others. Concentrators, so blow down concentrators using heat and nitrogen flow to concentrate samples quicker. Water chillers, rotary evaporators, vacuum pumps, centrifuges, PG blocks, so open digestion systems, thermostatic baths, and hot plates. So really, we can cover a complete range of sample prep equipment that we can provide to you thanks to Alt support. So today, the topic, obviously, it's Xelsius, so our reaction unit for organic synthesis and drug discovery processes. Before we start with the technical, let's say, presentation, I would like to show you a very short video, which is always quite useful to understand how the unit is connected, how the unit is running and functioning before to go into details with more technical and application details. So I will launch the video now. So 10 in 1 and much more. This was the last sentence in our video. So I believe the video is always quite useful and quick learning to understand the functioning of the unit. But what Xelsius is essentially, it's reactions provided with 10 different reaction chambers that can be managed independently one from the other in terms of temperature, time, and steering, covering a temperature range that goes from minus 20 degrees up to 150 degrees. The main applications that we are ourselves experiencing the more requests from. So obviously drug discovery, organic synthesis, screening, solubility processes and test, crystallization processes, root scouting, gravimetrical analysis, and design of experiment. So really every stage of organic synthesis and reactions, preliminary stage where we need to optimize our reaction flow and process before to scale up to pilot or implant scale in terms of pharmaceutical compounds or organic compounds production. What are the main goals that we want to achieve with Xelsius? So high return of investment. So compared to dealing with multiple heating mantles, highs, bath, condensing column, really to provide you with the unique solutions that will ensure the return of investment within the short, medium time. Easy to handle and reliable equipment. So optimization of your reaction processes, much more reaction, as well as saving space in your lab, because as you should understand, compared to using standard lab equipment, this will ensure a much small footprint compared to standard reaction approach, and lower your CO2 footprint. This is the main system, the one you see in the left. You have the actual reaction module. The one on the right would be the software unit, where we have all our soft and electronic components, the main touch screen, and the piping connections to connect the unit to the chiller and the cooling system. The Xelsius key features. So the efficiency, the and the flexibility, which I believe will be the key aspect, and we will guide you through later on. So in terms of high efficiency, imagine having to deal with standard approach, running 10 reactions at the same time. We have calculated that you will need essentially 10 heating platforms, 10 cooling platforms, and about 3 fume hoods. These, if we take these down to numbers in terms of expenses and CO2 footprints, the standard approach, running 10 reactions at the same time, would be comparison to 13 flights from Milan to New York per year. As you all know, we are moving to a greener world, or at least when trying to do our best to reduce our CO2 footprint within any type of activity, especially in laboratories. So this is just to know what standard approach looks like in terms of cost and CO2 footprint. Now, if we imagine using Xelsius, we only have one system, one fume hood, and this is the comparison between cost and CO2 footprint in comparison with standard approach for organic synthesis and multiple reactions. So from 13 flights, we went down to 2 flights from Milan to New York per year. This is how much we can lower the CO2 footprint using Xelsius instead of the standard multiple reaction approach. So now, this is just to show you very quickly how much we can save on multiple instrument purchase and CO2 footprint using Xelsius instead of going for the standard approach that we have always been used to. Now, high performance. So as you have seen in the video, the main functioning of heating and cooling is provided thanks to Peltier elements. Peltier elements are essentially small electronical chambers that allow you to cool on one side and heat on the other side. So the plus of using Peltier elements for heating and cooling the reaction chambers is that we have an extreme fast heating and cooling. So the heating rate is about 48 Celsius per minute. Cooling rate is about 36 Celsius per minute. And I'm sure you understand that when running endothermal or exothermal reactions, and we adding catalyst, we need to be sure that we are keeping the temperature stable, that we are providing enough fast heating and cooling to the system. And this is obviously thanks to the Peltier elements within the reaction unit. Another important aspect is the temperature stability. So thanks to our Peltier elements, we have tested the system, and we can grant in each cell a temperature stability of about 0.1 Celsius degrees. Now, coming to the flexibility, which I believe is the key aspect when talking about Xelsius, we have different accessories that we can provide together with the main unit, which essentially allow you to do with the system in terms of reaction and organic synthesis processes. So the first accessory is the reflux condenser. So you can place the reflux condenser on top of the main unit and ensuring that when you're running long time reactions, you're not going to lose any solvent or reagent vapors because they will be recondensing within the actual reaction chamber. We have the 5-port reaction cap, which Vinicius, our essentially is a GL25 thread cap, but the is that it's provided with 5 different ports that you can use in different ways to access the main reaction chamber. The inert workstation, essentially, it's a inert station with a 3-way valve system, which will allow the user to inertize and create inert atmosphere within all the reaction chambers at the same time. And this will obviously ensure that all your reactions are running under exactly the same conditions in each reaction vessel. We have different reaction vials and caps going from glass vessels to PTFE vessels, many other different volumes from 30 ml to 5 ml vessel volume for small reagent reactions. We have a filtration stick which can be placed inside each reaction vial, so you will be able to sample from each vial, avoiding solid particle to be within your sample, and then carrying on with your further analysis like GC or ICP, directly sampling and analyzing. We have 10 different temperature sensors, so beside the actual temperature control of the main chamber, you will be able for each position to measure the actual temperature of the sample while it's heating or cooling. This is one of the most recent accessories that we have added to the main unit. Is a dosing station. So essentially it's a 2-channel peristatic pump that you can use to program microliters volume additions within all the 10 reaction vials. You can monitor the addition, you can control the addition, and really you different range of your volumes and time for the dosing of catalyst or reagents. Now coming to the new accessories, so the one is the pressurized vessel. This is already available for the international market. Essentially, this will allow you to run reactions that will reach up to 15 bar internal pressure. And we also have internal adapters, either in glass or PTFE, which will allow you to use different acids and work in an acid environment within the actual pressurized reaction chamber. Now, coming to the accessories that we're still developing, this is the turbidity sensor, which will allow you to control the solubility and turbidity curve of your sample while the process is actually running. Another new accessory that we're developing, let's say we are at the final stages of development, is the photochemistry probe. Essentially, you will be able to insert inside the vial different lamp of different length wave to catalyze and to, let's say, flow energy within your reaction vial. Besides all the accessories that you have seen, we have, of course, application and reaction books that we can share with you. That essentially we have developed together with the University of Turin, based in Italy, which is helping us collecting data and developing real application and reaction book for both distributors and customers. Short slide of all the partners and customers that so far has been using and testing Xelsius in their lab. As you can see, this is some of the most famous pharmaceutical and organic chemistry based customer probably all over the world. So that was it concerning my introduction to the system. I guess now we will go with Vinicius' presentation. So I will just stop sharing my screen with all of you. And I will leave the speech to Vinicius, which will show you practically how we manage to control the system and what the system can actually do.
Thank you, Matteo. Thank you for your great presentation. Good morning, everyone. My name is Vinicius Manzoni. I'm a product manager of Xelsius. And today, I would like to introduce you the system, and I will divide my presentation in 3 main parts. The first part, I will talking about the hardware itself of Xelsius, the benefits, the features of the Xelsius. The second part, I will introduce you to the software, how it's simple to manage the software, how it's simple is to use the software. And the third part, I will talking about the accessories. One key point of Xelsius, the flexibility. So let's start for the hands-on, talking about the Xelsius itself. So the hardware of Xelsius itself, we can see the first benefit or the first feature of the Xelsius system is the size. In a very small footprint, we are able to run up to 10 reactions. So in a small footprint, less than a half film hood, I'm able to handle temperatures from -20 up to +150. The second point that I would like to touch is why the system is white. It's white because it's PTFE covered to guarantee 100% that system it's very well protected against aggressive environmental, inside of film hood. The touchscreen can be placed in different places, even outside of the film hood, because it's connected with a single cable. So there is one USB in front of the instrument that allowed you to export the data. So it's possible to export the temperature set, the temperature inside the liquid, if you are using an external temperature sensor, all the parameters every 1 second in one Excel file. So, and the system, it's able to handle different accessories. Now, let me show to you the software itself and talking about how to programming the system and show to you how it's simple is. For it, let me zoom in to allow you to see the screen. So I think now you are seeing very well the screen. So here we have the 10 position of Xelsius. The position, for example, how to set one temperature for Xelsius system. For example, goes to the position 3, click on the position, and you see the parameters menu, where I'm able to place the TJ. TJ means temperature in the jacket. So here I can set, for example, 100 Celsius degrees. It's possible to set a ramp in max speed. Max speed means the system will push very fast the temperature up and down. How much? +48 for heating and -36 Celsius degrees per minute for cooling. Or it's possible to create a ramp Celsius per minute or Celsius per hour. It's possible to set RPM for the steerer, because each position, each chamber has your own steerer driver. So, for example, in this case, let's leave 0. And timer, set a timer in case of I would like to shut down the position after a couple of minutes, a couple of hours, for example. And I would like to use now, because with the system, we already have a pumping dosing station attached. When you attach the dosing station, appear to you the icon for the pump. So now also for the Xelsius parameter menu, it's possible to select to set a volume in microliters and also determine a flow rate in microliters per minute of the pump and dosing. So directly from the Xelsius software, it's possible to dosing a volume based in the total volume and also for the flow rate and dosing the reagent direct to the vial without programming a standalone pump. Also, all those data will be saved and can be stored in Excel file through the Xelsius software. So I'm already set those parameters, and if I would like to export those parameters for the other positions, just to click in the edge of the system, and all those parameters also will be exported for the different positions. Now, click OK. I already set for the position 3, 4, 5, 7, and 9, 100 Celsius degrees. Let's set a very completely different temperature in the position side by side. For example, position 4. Let's set, for example, doing the same idea, minus 10. So I'm set minus 10, the same procedure that we did before, and now click OK. So now position 3 is set in 100 Celsius degrees, and position 4 set in minus 10 Celsius degrees. So to start the position, to heating or cooling, now what you need to do is press play. When the position becomes green, the system starts to heating and cooling the position. Okay, this is for a single temperature. Maybe now you are asking me, Vinicius, and if I would like to create a ramp, create a profile with a different points, it's quite easy too. So go to the thermometer here, the little thermometer that we have here, click on it, show now appears to you one graphic area. Now when you click in the temperature, now show to you the profile mode. So the profile mode allowed you to start a reaction in a certain temperature, increase the temperature, after decrease the temperature based on time. For example, it's possible to start, let's start the temperature at 0 Celsius degrees, keep this temperature for 5 minutes, for example. Also, it's possible for each position set a different stirrer speed. So if I'm, for example, doing one reaction that I need to add a catalyst, I can start stirring it. Let's heat it to 110 Celsius degrees. Do it, for example, in 10 minutes. The system will calculate alone, standalone, the curve, the ramp. After, keep this temperature for a half hour, and let's simulate one crystallization that take a lot of time or so. After do the reaction, after do adding the catalyst, I need to cooling very, very slowly to create a crystal. So let cooling to 20 Celsius degrees in 10 hours, for example. So the system will cooling from 110 Celsius degrees, cooling to ambient temperature, 20 Celsius degrees, in 10 hours. In that time, let's shut off the stirrer driver. So I'm create a profile for crystallization, for example. And also, if you are not doing a crystallization, doing a different process, it's possible to do it in circles. So I can create it 5 times, up to 100 times if I'm doing some reaction that I need to heating and cooling. One good thing is I've created this profile. Now it's possible to save it in the internal memory. So again, tomorrow or next month, when I need the same parameters, I go here and load the profile. So still here my information, my profile, and the same idea as we did before. To export those parameters for the other positions, just click here in the circles. When you click OK, you see the same parameters for the all positions. What I need to do is click and start, and the system starts to heating and cooling. Now, when I click on the graphic area, it's possible to follow. As you can see, we have here 5 profiles to heating and cooling very slowly. You start to see a red line is the line for the temperature in the jacket. And if I would like to export those data, goes here in this strat here and export to Excel. So I already have here one Excel file that I'm able to save in external memory, external memory flash, and work with this data without problem with the TJ, the temperature in the jacket, the time, and the power and the stirrer driver speed. So it's quite useful and simple to use. Now, we less than 1 minute we already reached 100 Celsius degrees for the cell 3 and minus 10 Celsius degrees for position 4. But just to give you an idea, I already prepared in the position 1 and the position 2 two different temperatures. So in the position 1, we are running 17 Celsius degrees. In the position 2, minus 15. And I put some water inside the vials just to give you an idea and how it's close one vial for the other. So just to give an idea, this is position 1 and this is position 2. So as you can see, the position 1, there is a vapor of the water, condensation here in the vial. So it means that the system is hot. And the position 2, we have the water freeze, the frozen water. So side by side, two different conditions running together without one affect the other. Quite a smart system. Now, let me talk about the accessories. So one key point of Xelsius system is be flexible, because we know that you are working with researchers, working with the new developments, new moleculars, and be flexible, it's a key point. Starting from the type of vials. So we have different size of vials. The common one is the vial with the 30 ml. So I'm able to work from a half ml up to 30 ml, 30 ml. But maybe you are asking me, Vinicius, and if I would like to work with a small volumes for a micro scale, micromole scale, we have the small one, the vial that it's a narrow bottle, so to guarantee the heating and cooling properly, and the system it's able to handle it from 0.1 ml up to 5 ml. Maybe you are asking me, okay, Vinicius, I see that a different body between the standard one and the small one. And if I'm put in the Xelsius chamber, there is no contact between the chamber and the vial. For this small one, we have an adapter here. It's quite easy to be removed, and we guarantee the contact between the vial and the chamber with the same material that we have inside the chamber. And to place inside the chamber, it's quite easy, like this. And now I'm able to work with a small vial. The both vials, or all vials, has GL25 threads. So a normal, very common thread in the lab to add different accessories to different another glassware, so a standard thread, all those vials, including a different materials. So for example, if I'm working with the fluoridic acid that's not allowed to work in glass, we also have PTFE vials, different materials, also very thin material to guarantee the proper heat transfer between the chamber and the sample. Another interesting accessory that Mateo told us before is the 5-port reaction cap. So sometimes we need to add something or remove or sampling something from the vial. For this reason, we create a 5-port reaction cap. It's a cap that we can use in different size of vial that give you 4 ports, 1, 2, 3, 4 ports, and 5 ports for sampling that you can sampling use a needle. So I can replace those connectors, put one connection for place a syringe, for example, another one for introducing a gas, another one for introducing the external temperature sensor, and even I can put a blind cap for create an inert atmosphere for doing whatever you want. So this cap, it's a key point for the flexibility of the system. So I'm able to do a lot of things, introducing sampling, introducing gas, burbling, hydrogenation, create an inert atmosphere with argon, whatever. So give you flexibility. And also, together with the 5-port reaction cap, As an example, we have the filter sticker. So it's one filter that, one sticker that inside has a filter. The idea here is place a filter here inside, place inside the vial, put the cap, do my reaction, and when I'm introducing one needle, for example, with the syringe, when I'm introducing to the vial, I'm already filtrating at the same time. So, for example, it's quite useful when I'm doing some studies for solubilization. So I'm create my product, I'm starting to analyze their solubility. I need to sampling every 1 minute or every 5 minutes, and if I'm doing normal way, I need to sampling, filtrate it after sampling before to inject in one GC, one HPLC. With this accessory, I can do it in the one step and save time. Another important accessory that I'd like to introduce you today is the external temperature sensor. So in the back part of the system, there are 10 connections, 10 connector, one connector for each position. So it's possible to connect a PT 1000 external temperature sensor to following the temperature inside the liquid and following or monitoring this temperature through the software. So the software will show me the TJ. TJ means temperature in the jacket, and TR, temperature in the reaction. So with these two numbers, also show me the delta T, the temperature between one and another. Because sometimes, for example, especially for the crystallization, it's quite important following the temperature in the liquid. Of course, every liquid has your own heat in absorption capacity, and depends on the temperature that you set, for example, 20 Celsius degrees, the liquid will be 19 or even 100 or 21 Celsius degrees, and it's possible to follow in this temperature by the software. Another important accessory is the reaction vial vessel. So it's an aluminum body system with the three-way valves that allowed you to have two ways to introducing or to sampling something during the reaction, and one safe valve. The safe valve will release the pressure in the 50 bar, so 50 bar, but the system are able to handle it, normal operation, up to 15 bar, 15 bar, and there is, in this case, one analogic manometer to follow the temperature inside the reaction. And to mounting, it's quite easy. So we have the cap, we have, in this case, the PTFE body, and now it's possible to place here up to 7 ml. Also, there is the possibility to work, okay, Vinicius, I'm not able to work with the PTFE, I need a glass vial. So there is the glass vial. With the PTFE vial, you are able to work up to 10 ml. If you introduce the insert in glass, it's possible to work up to 7 ml. So much flexibility for high pressure vessel, for high pressure reactions. Here we have the dosing station. The dosing station, as we see before in the software, is totally controlled by the software. We have two heads with the piston pump, where I can adding reagents to my vials independently of the position. Also, it's possible to choose the position that you would like to add in the dosing station. The dosing station are able to handle it from 25 microliters per minute as a flow rate up to 4,000 microliters per minute, or 2.5 ml, 4 ml, so 4,000 ml as a flow rate. So from 25 microliters per minute up to 2,000 microliters per minute, and can dispense it up to 25 microliters, up to 25,000 microliters, or even 25 ml. It's complete, and also, if you want, it's possible to operate standalone using the key in the dosing station. Another important accessory that we have here is the inert workstation. The inert workstation, it's a very smart device that are able to substitution or to replace the atmosphere up to in 10 vials at the same time. We place the vials here, connect in series one by one, using a three-way valves plus one vacuum pump and one inert gas, flushing, removing the air with the vacuum pump and flushing the inert gas. Normally we do it 5 times. We guarantee the same condition for all vials in the inert workstation. And after finish the process, disconnect the smart connectors. You can place all the station and place in the Xelsius system and do your parallel synthesis using an inert atmosphere at the same time. And the last accessory that I would like to touch today or to introduce you today is the reflux condenser. Maybe you are asking me, okay, Vinicius, sometimes I'm using a condensation column or using another system to create a reflux phenomenon in my vials because I'm working over the boiling point. Step by step, my solvents start to evaporate. I would like to keep it for not to become dry. I put a condensation column. As we have a very small space here, footprint, if you try to put 10 condensation column here, will be a mess, a lot of tubes, glassware. There is no idea for Xelsius system. So for this reason, we create a reflux condenser that less than 1 minute, we are able to place all vials in my Xelsius system in that way. So in less than 1 minute, I can install, set up, and using the same tubes from the chiller that's cooling Xelsius system, create a 10 condensation zone here. So now I can work over the boiling point and create the reflux condenser phenomenon like if I have a 10 condensation columns here. Save time, save money, not buy 10 different condensation columns, and it's a very, very useful accessory. Of course, Mateo already introduced you. We are still developing a new accessories. All those new accessories will be fit inside the Xelsius standard system. So when we start to design or when we start to thinking in new accessory, always will be fit in the Xelsius platform because we see Xelsius as an open platform. We are working the photochemistry, we are working turbidity test, and we are working also in another accessories that will be in the next years to come, auto sampling, automation, and other things, and always will be fit inside the Xelsius system. From my side, that's all. Now we can go for the Q&A part, question and answer. Will be pleasure to be here and answer your question and doubts. Thank you.
Thank you, Mateo and Vinicius. That was great. Якщо у когось є запитання, пишіть, будь ласка, в чат, і ми задамо безпосередньо Матео і Вінісіусу, і вони зможуть нам допомогти з вашими питаннями. Якщо, можливо, у вас виникнуть питання потім, в кінці ви отримаєте листи з записом, і там будуть наші контакти, куди ви можете звернутися там для отримання пропозицій або для отримання більшої кількості якоїсь інформації, можливо, брошури для ознайомлення. Тому будемо чекати ваші запитання.